In electrical circuits, there are two combinations of electrical components that can be combined in various ways. The first of which is called a series circuit. In a series circuit, the electrical components are connected on a single current. So I have an example of a series circuit here where I have a potential difference due to a battery driving a current out of the positive terminal, which is labeled as the longer of the two, which would drive an I this direction around the circuit. And so I have three resistors built into the circuit, R1, R2, and R3. These could be anything from a blender to a light bulb to just an electrical resistor that dissipates the energy in terms of heat. No matter what, there is a single current through this wire because there is only one pathway for the current to flow. And so in this particular case, R1, R2, and R3 are all affecting the circuit, which means they are all experiencing the same current. And if we think about Kirchhoff's rules, which the loop rule says that any closed loop, the total potential must be zero. And so 0 being equal to the voltage added by the battery minus the voltage supplied by, or being utilized by, by resistor 1, resistor 2, and resistor 3. In other words, the potential difference being supplied by the battery is divided equally amongst the three components. Now, in this particular case, that is only true if R1, R2, and R3 are equal, but nevertheless, this statement allows us to say that the total voltage is a function of each individual potential difference across each electrical component added together. And so if I substitute in Ohm's law for these, then we have I times R1 plus I times R2 plus I times R3. And so the total voltage is a function of current, which is the same in all cases because remember there's only one, times the sum of the resistances, R1, R2, and R3. So in series circuits, it's appropriate to say that the equivalent resistance, or Req, which is defined as the resistance equivalence for the circuit, or the total resistance for the entire functionality of these electrical components. In other words, in a series combination, the equivalent Req can be written as just the sum of all the resistances being applied. And so this is often written like this: sum from I equals 1 to 0 of all R's. Or, in this particular case, R1 plus R2 plus R3, etc., if there were more.